Welcome to ETE MCQs. Let us solve a problem in digital circuits. So we are given a sequential circuit constructed using two JK flip-flops. Consider the circuit shown below. What would be the output sequence when the input sequence x is equal to 0, 1, 1, 0, 0? Assume the initial state AB is equal to 0, 0. So we are given a sequential circuit, the input sequence x is given. Assuming that the initial state to be 0 and 0, since you have two flip-flops, okay, you have two outputs, they are represented by A and B. Assuming that the initial state to be 0, we are supposed to find the output Z. Z is your output. We are supposed to find out Z. This is what we are supposed to find. J and K input of flip-flop A and B has got different Boolean expressions. The Boolean expressions are different. J and K are not fed directly with the inputs. Okay, so first let us find the Boolean expression for flip-flop inputs. We are supposed to find the Boolean expression. So the flip-flop inputs are JA, KA, JB and KB. So first let us find out what is JA. JA has got the interconnects from the output of, let me call this as 1, 2, 3, 4 and 5. Let us take the inverter as number 5. Okay, so 3 has got input from the gates, the NAND gate 1 and 2. So if you notice, the output of the first NAND gate is, let me just represent this particular junction as M. Okay, so M is nothing but X dash B. Since it is a NAND gate, the output of the NAND gate is given as, in general, if it is AB, you will have A dot B the whole dash. Since it is X dash B, X dash and B, that is given as input to the NAND gate, you will have X dash B dot B the whole dash. So this is your M. Now KA is nothing but M bar, because here M is given as input to the inverter, and here the output of the inverter is going to be M bar, which means that KA is equal to, or M dash or M bar, both of which are correct. So M dash is nothing but X dash B. Similarly, what is JA? JA is nothing but, it has got two inputs, one is M and the other one is, here the product term we will get is, the output of this NAND gate will be XB dash the whole dash. Here you will have X B dash the whole dash, because this is an AND gate, so the dot product of these two inputs and whole dash, you will have XB dash the whole dash. That is given as input to the NAND gate 3, whose output is nothing but JA. So JA is nothing but M dot X B dash the whole dash because this is one input, XB dash the whole dash is the other input, so it is A dot B the whole dash based on De Morgan's law. X dot Y the whole dash is equal to X dash plus Y dash, and the other dual is X plus Y the whole dash is equal to X dash dot Y dash. So this is De Morgan's law. Now When you just apply De Morgan's law here, instead of x you have m, and instead of y you have xb dash the whole dash. M is nothing but x dash b the whole dash taken dot product with x b dash the whole dash, and overall you have a whole dash. Now here we are going to apply the De Morgan's law for this part and this part. So based on that we have x double dash plus b dash Boolean and with, here it is, x dash plus b double dash the whole dash. So this is nothing but x double dash is x plus b dash taken Boolean and with x dash plus b the whole dash. So this is nothing but you just take perform Boolean addition so that you get x dot x dash x dot x dash plus xb plus b dash x dash b dash x dash plus b dash b the whole dash. This is what we have. Now you can notice that x dot x dash is, this becomes 0, b dot b dash becomes 0. So finally you will have JA is equal to xb plus x dash b dash. Since it is commutative, I can just rearrange it, the whole dash. Now xb plus x dash b dash is nothing but x nor b the whole dash. X nor b the whole dash is nothing but x XOR b. So this is your JA. JA is nothing but x XOR b. Likewise, the Boolean expression for JB and KB has to be identified. So we are supposed to identify the Boolean expression at this node. So what do we have? JB and KB, both of which is equal to JB is equal to KB because both shares the same input, is equal to, since x dash and a dash is given as input to a NOR gate, you will have x dash plus a dash the whole dash. That is two inputs, x, y, x plus y the whole dash. That is the Boolean expression for NOR gate. So JB KB is equal to, this can be further rewritten as, when you apply the De Morgan's law, you will end up with x double dash dot a double dash. X double dash is nothing but x and a double dash is nothing but a. So you have x into a. So this is your JB is equal to KB. JB and KB is equal to XA. Now the four Boolean expressions are identified. JA is equal to x XOR b, KA is equal to x dash b, JB, KB, both of which are equal to x into a. So the Boolean expressions for the inputs are identified. Now let us go for the transition table. We'll have the transition table will have the input x. X is your input. Next you will have the flip-flop inputs JA, KA, JB and KB. JB and KB. And then you will have the output, respective output A, B of the flip-flop. A and B are outputs of the flip-flop. The overall output is Z. So the transition table is being constructed with input X. The flip-flop inputs are JA, KA, JB, KB. The flip-flop output is represented by A and B. The overall output of the sequential circuit is Z. The input sequence that is given is 0, 1, 1, 0 and 0. Okay, initially it is assumed that the initial state is 0 and 0. Okay, the initial state is assumed to be 0 and 0. A and B, the flip-flop output is taken to be 0 and 0. Now, since initially it is mentioned that A and B both are 0, let us just substitute A, B along with X input so that we get the now irrespective of the value of JA, KA, JB and KB, initially the output of both the flip-flops are 0. So let me represent the JA, KA, the inputs of flip-flop by a don't care condition, which means that because this is the initial state which produces a 0 output for both A and B. Okay, now this will be your AB and the present X will be considered. Present input will be considered. Now you can notice, so I'll be making use of this A and B along with the X we have here. Okay, during the next edge triggering, this is a negative edge triggered flip-flop. So during the next negative edge triggering, I'll be considering this input and the previous output because this output is produced and it is intact. It is this output that along with the input produces the next state output. So I'll be making use of these two outputs of A and B along with the input to find the next state output of the flip-flop. Finally, I'll find out the overall output of the sequential circuit. So A and B both are 0 and X is 1. So what do we have? What do we have for JA? JA is nothing but X XOR B. X is 1 and B is 0. 1 XOR 0 is 1. Okay, and then Ka is nothing but X dash B. X dash is 0, B is 0. So 0 dot 0 is 0. JB is X into A. X is 1, A is 0. So you will get a 0 and 0. We know that from JK flip-flop, we know the truth table of JK flip-flop. JK flip-flop, next state output is represented by n plus 1, 0, 0, 0, 1, 1, 0 and 1, 1. When J and K both are 0, the previous output is retained. That is Qn. For 0, 1, the output becomes 0. For 1, 0, the output becomes 1. And for 1, 1, the present output, whatever you have, will toggle. Okay, if it was 0, it will produce a 1. It becomes 1. If it is 1, it will produce a 0. So based on that, you can notice JA is 1 and KA is 0. KA is 0. So the output should be 1 based on this particular condition. J is 1, K is 0. So A becomes 1. Whereas JB and KB both are 0. So the previous output will be retained. B remains 0. Next. Now we will be taking this output and this input to produce the next state output. Next, what do we have? Again, JA is X XOR B. X is again 1. X remains 1 at the input. And X XOR B, 1 XOR 0 is 1. JA is 1. KA is X dash dot B. X dash is 0. Dot B is 0 again. JB and KB. For JB and KB, you have X dot A. Okay, X is 1. A is 1. So JB becomes 1. Also, KB becomes 1. Because JB, KB both are equal to XA. Now, what will be the present output? The present output for 1, 0, for the first flip-flop, the output is 1. For 1 and 1, this state will toggle. It will toggle so that 0 becomes 1. Here there is a toggle. I am just mentioning it by a dotted line. Here you just have a toggle. 0 toggles. The reason is that you have JB and KB to be 1. So 0 toggles and then a 1 is produced. Next, we have AB 1 and 1 and X is 0 now. What is JA? JA is X XOR B. X is 0, B is 1, so you get a 1. KA is X dash B. X dash is 1, B is again 1, so you have 1 again, 1 and 1. What is JB and KB? It is XA. X is 0, A is 1, so you get a 0 and 0. So for the first flip-flop, JA and KA, the output should toggle. The output should toggle. In that case, the present state is 1. So once this toggles, you will end up with, there is a toggle over here, due to which 1 toggles and a 0 is produced. When JB and KB both are equal to 0, the previous output is maintained. So 1 remains at B as such. Next again, for JA, we have X XOR B. X is 0, B is 1. So you will have a 1 here. And X dash B. X dash B is KA. KA is X dash B. So X dash is 1, B is 1. Again you have a 1 and 1. And JB and KB both are is equal to XA, which is 0 and 0. 0 and 0. So once you have 1 and 1 for JA and KA, the present output toggles. So 0 toggles to 1. For 0 and 0, the previous output is maintained. It is retained. Okay. Now we haven't obtained the Boolean expression for Z. Okay. We are done with the transition table. We are supposed to find the overall output Z. What is the Boolean expression for Z? If you just notice, Z is nothing but Z is equal to A dash and B dash are given as input to the NOR gate. The output of NOR gate is Z. So you will have A dash plus B dash the whole dash. A dash plus B dash the whole dash. Again you apply De Morgan's law. You will have A double dash dot B double dash. So which is equal to A double dash dot B double dash, which is equal to AB. So you will finally end up with AB. So Z is nothing but AB. So the dot product of A and B is 0 here. 1 dot 0 is again 0. 1 dot 1 is 1. 0 dot 1 is 0. 1 dot 1 is again 1. Therefore, the output sequence we get for Z is nothing but 0, 0, 1, 0, 1. So this is the output sequence we finally obtain for the given sequential circuit constructed using 2 JK flip-flops. Okay. So the option matches with B. So B is the correct option. Thank you.